Okay, in this tutorial, we're going to make a math model for a nonlinear set of data. So the question is, how does the distance that a marble rolls down a track, how does that distance depend on the time that it has been rolling? So first of all, we'll take a quick peek at our data. We'll highlight it. We'll go to Insert, Chart. And over here on the chart editor, under chart type, we're going to scroll down until we find scatter chart. We're always going to use a scatter plot to look at relationships between data. So you can quickly tell here that this data is curving. It's not a straight line. That's how we know it's nonlinear. So our job is to figure out what sort of functional form does this have? Can we get this line straight? So from our history of mathematics, we know that a graph that looks like this is possibly a parabola. And so for a parabola, y equals x squared. So we're going to take that as a first guess and see if that works out for us. So remember, when you're graphing data, the first column is x, the second column is y. And what we want to do is actually graph not x and y, but we want to graph x squared and y, because we think that y is related to x squared based on the parabola. So this is not going to be time, this is going to be time squared, because we're going to graph x squared, and this is going to be a goofy unit of seconds squared. And what we want to do is square all of the numbers here, all of the x data here, and here we're going to have x squared. A quick way to do that is to start by typing equals, click over here, so that's a8 to the second power, copy that formula down, and you will get each of the values of x squared. So now, let's take a peek at this. Is there a relationship between y and x squared? So we're going to again go to Insert, Chart. We are again going to choose column chart type and scroll down to Scatterplot. And here we go. We have a nice straight line. There's a linear relationship between y and x squared. Okay, I'm going to go to Customize and finish up now. Under my titles and subtitles, my chart title is always going to be the same. We're going to say the relationship between the distance, because that's on our y-axis, and on our x-axis we have time squared for a marble rolling down an incline. So we have a nice descriptive title there. We're going to go to subtitle. Our subtitles are always the same. It is our name, a delimiter, the date, the period, so this is period 2 for example, and this is lab 00 or whatever lab it is. Okay, and that's the end of our labels, and you can see they all showed up here, the title and the subtitle. Next we go to where it said chart title and subtitle, we can go to horizontal axis label. And remember, on our horizontal axis down here, we don't have time, we have time squared, or maybe the square root of time, or whatever you had to do, and the units are seconds squared. And on the vertical axis, we still just have the position or the distance it rolled. So my graph's looking pretty good here. I've got most of the conventions. You can click on this to collapse that. Let's go to Series. Under Series, we want to add a trend line. We will find a line of best fit, and clearly a straight line does a good job. We always use linear here. Keep scrolling down. Under Label, you can choose Use Equation. And here, the thing I want you to note is the slope. This is basically saying y equals 0.438x plus a very small intercept. My intercept looks like it's 0 here, so I'm going to go with 0 for my intercept. So my math model is going to be y, which in this case is the distance or position, equals the slope 0.438 times what's on my x-axis, which is time squared. So over here on the right, I'm going to change this again. You have to go to Use Equation to see the equation, but now I'm going to go to Custom, and I'm going to type in what I had there. So that is y, which is the distance, equals 0.438 438 times x, which is time squared. And I'm going to ignore the intercept. And so that's my mathematical model. And so now we are finished with customizations. You could actually move the location of your legend here if you want. You can put it on the inside, which just makes your graph a little bit bigger. It puts it right there. And that's what we're after, right there. So you can make this a little bigger if you want. I'm going to minimize that. So here is the final product. This is what we are after. We have found that the position, distance, equals 0.438 times the time squared. Now, if you tell me the time, I can plug it in my equation and I can tell you the distance. Or if you tell me the distance, I can solve for the time. That is what we're after. That's the relationship. And so finally, to finish the conclusion, right here, I can say that the distance is proportional to, and then whatever I graphed on my x-axis to get my line straight. So the time squared. And there we go. We finished up the job of finding the mathematical model for this relationship. We know the nature of the relationship, the distance is proportional to the time squared, and we know the exact functional form. We know exactly how to find the distance if you know the time, or to find the time if you know the distance.